In this chapter, we will discuss additional introductory topics that are vital for the understanding of structural and mechanistic organic chemistry. We will learn to write electron dot, Kekule, and condensed structures for simple organic molecules. We will learn to classify organic compounds based on their functional group. We will learn to expand condensed structures to Kekule structures based on the concept of valency. We will learn to define Arrhenius and Bronsted-Lowry acids. We will learn to predict on which side the equilibrium would lie in an acid-base reaction. We will learn about Lewis acids and bases and predict the products formed when a Lewis acid reacts with a Lewis base. Writing structures based on the concept of valency. In this section, we will learn to write the electron dot structures, Kekule structures, and condensed structures for the compounds that hydrogen forms with PD2 elements. Lewis electron dot structures of PD2 elements are given here. The number of dots around each element represent the number of valence electrons, that is, electrons in the outermost shell. Lewis electron dot structures for the compounds that PD2 elements form with hydrogen. The structures here show sharing a pair of electrons to make one bond. The number of valence electrons that an element uses for making bonds with other elements is their valency. The valency of lithium is 1 since it uses one electron to form lithium hydride. The valency of beryllium is 2 since it uses 2 electrons to form beryllium hydride. The valency of boron is 3 since it uses 3 electrons to make borane. The valency of carbon is 4 since it uses 4 electrons to make methane. The valency of nitrogen is 3 since it uses 3 electrons to make ammonia. The valency of oxygen is 2 since it uses 2 electrons to make water. The valency of fluorine is 1 since it uses 1 electron to make hydrogen fluoride. In Kekule structures, each bond is indicated by a line. The lone pair electrons on nitrogen and oxygen are indicated since they play an important role in chemical reactions. In condensed structural formulas, the bonds to each hydrogen atom are not shown. The number of bonded hydrogens to all elements are shown with subscript numbers. Classification of organic compounds according to functional groups. Organic compounds are classified according to the functional group present in them. The functional group has a bearing on the physical properties and chemical reactivity of molecules. In this section, several classes of organic compounds are listed and their functional group indicated. Also given here are one example from each class of compounds with their common and IUPAC names indicated. It is important to study these compounds and know their functional group for mastering this chemistry. Class of compounds: alkane, exemplified by ethane. Functional group: hydrogen. Class of compound: alkene, exemplified by ethylene. Functional group: pi electrons. Class of compound: alkyne, exemplified by acetylene. Functional group: pi electrons. Class of compound: arene, exemplified by benzene. Functional group: pi electrons. Class of compound: aldehyde, exemplified by acetaldehyde. Functional group: carbonyl group. Class of compound: ketone, exemplified by acetone. Functional group: carbonyl. Class of compound: acid chloride, exemplified by acetyl chloride. Functional group: acid chloride. Class of compound: anhydride, exemplified by acetic anhydride. Functional group: anhydride group. Class of compound: ester, exemplified by methyl acetate. Functional group: ester group. Class of compound: carboxylic acid, exemplified by acetic acid. Functional group: carboxylic acid group. Class of compound: alcohol, exemplified by ethyl alcohol. Functional group: hydroxy group. Class of compound: alkyl halide, exemplified by ethyl bromide. Functional group: halogen. Class of compound: ether, exemplified by dimethyl ether. Functional group: ether group. Class of compound: thiol, exemplified by ethane thiol. Functional group: thiol group. Class of compound: amide, exemplified by acetamide. Functional group: amide group. Class of compound: nitrile, exemplified by acetonitrile. Functional group: nitrile group. Class of compound: amine, exemplified by methylamine. Functional group: amine group. Expanding condensed structure to Kekule structure. In order to expand a condensed structure to a Kekule structure, it is important to know the valency of all the elements in the structure, as well as the type of bonds, single, double or triple bonds, that they may make with other elements. A knowledge of functional groups will greatly help, since atoms like oxygen or nitrogen are present in many functional groups. Many times one may be able to write more than one Kekule structure for the same condensed structure. Example: expand the condensed structure C2H6O to a Kekule structure. The above condensed structure can be expanded to a Kekule structure in two different ways. Both structures are valid structures, obeying all the rules of valency and octet rule. The two structures, ethyl alcohol and dimethyl ether, are structural isomers of each other. Expanding a condensed structure to a Kekule structure. The condensed structure C3H6O can be expanded to three different Kekule structures: acetone, acetaldehyde, and methyl vinyl ether are all structural isomers of each other.